Starting now, ask me a question.
7, 8.
Which one?
7,
Which one?
8. 7.
7 and 8.
You know we're wasting time.
7.
There you go.
Glaring at board.
Number 7. Let me turn the lights off or something.
Yeah, that'd be great.
Go back here and turn on that little light. Kind of gives off light.
No, I didn't know that.
Sorry. Yeah, I was good all day yesterday. I didn't make those smart aleck comments, but Evan, I don't know, you just must bring it up and there's some, and switch it again. Whoever sits behind you switches it. Because they don't want it either in some other class. All right, we got this, and they tell us this is a square. They want us to find the area. What's the formula for area of a square?
No, it's length times width.
Length times width, right? It's just length times width, not for a triangle. So we got this, that's 11. What do we know when we draw a diagonal in the square? What do we know about this triangle?
It's similar to that triangle.
It's similar to that one. What else? What kind of triangle is it? This is what we covered last time. 45, 45, 90 triangle. It's 45, 45, 90 triangle. In a 45, 45, 90 triangle, side across from the 45-degree angle should be labeled L. Side across from the other 45-degree angle. Side across from the right angle.
L times the square root of 2.
L times the square root of 2. Let's try to hurry through this so we can get, the more problems we get done, the better off for you, right? L radical 2, we know now equals what? 11. Since they're asking us for the area, let's just do the decimal form on this one. So have your calculator out. What I do to solve for L?
But L,
Divide by radical 2. So just take 11 and divide it by radical 2. We'll take the decimal answer this time.
7.778.
7.778.
Yes.
So we'll say 7.8. How long is this side in this square then?
7.8.
7.8. How long is this side?
7.8.
7.8. What do we do to find the area? 7.8 times 7.8. Somebody do that.
60.64.
60.64? 84. So we'll say 60.8, round it off to nearest 10. Did they give us any units? Meters. And if it's area, what is it? Meters squared. Good. Next question.
12.
How could, before we go on to the next question, how could I find the area of this triangle right here from the information we have right now? Divide that by 2. Just divide by 2. The area of the square is going to be double whatever the area of each of these triangles are, right? Which one next?
12.
12. Problem 12. They give us this time. They tell us this angle's 30, this is 90. What's this angle then? 60. So what kind of triangle are we dealing with? 30, 60, 90. This is X, this is Y, this is 20, is that 26?
Yeah.
In a 30, 60, 90 triangle, the side across from the 30-degree angle should be labeled what?
L.
Side across from the 60-degree angle?
L radical 3.
L radical 3, good. Side across from the right angle?
2.
2L. What equation are we going to set up this time? 2L equals 26. How do we solve for L? Divide by 2. What's that give us?
13.
So L equals 13. Everywhere we see L, then what can we put in there? 13. So if we put in 13 right here, what's X? X equals 13.
Yes, yeah.
If we put in 13 right here, what's Y? 13 radical 3. Next question. 8. So everybody got that before I erase it? Yes, no, maybe?
Yeah.
Number 8, find the area of this triangle. What's the formula for area of a triangle? 1/2 times base times height. They tell us that this is an equilateral triangle, so all those sides are the same. This side down here is 20 yards. So if that's 20 yards, what's the height of this triangle? Do we know it? No. To find the height, we need to draw in a what? What's that called?
Altitude.
Altitude. We need to draw an altitude. When you draw an altitude in an equilateral triangle, what kind of triangle is each of the little?
Or
30, 60, 30,
Which one is? I heard both answers. So 30, 60, 90. That angle's 60, that angle's 30, that angle's 90. In the 30, 60, 90, first, what do we know about this side?
It's 20.
It's 20. All right, this side? 20. In the 30, 60, 90, side across from the 30-degree angle should be labeled what? L. Side across from the 60-degree angle? L radical 3. That's the height. That's what we're looking for, right? Side across from the right angle? 2L. So we got 2L equals what? 20. What's L equal then? 10. What can we put in? What can we put in right there? 10. Now, since we're finding the area again, that side is 10 radical 3. Let's change it to a decimal. What are we going to change this 1/2 into? 0.5. What's the base of the triangle? 20. So 0.5 times 20 times, somebody change that there to a decimal form. 17.3. Multiply all those together. What is it? 173. No decimal? No decimal. 173, what was our units? Yards. Square. Next question.
45. This changes to not 25. 23.
Which one? 23. 23. Is that a 30, 60, 90, 45, 45, 90 triangle or what? 30, 60, 90? No, yes. Is it?
It looks like it.
It looks like it. Is that what we go by?
You don't know what it is.
We don't know what it is. So can we use 30, 60, 90 stuff on it? No. Can we use 45, 45, 90 stuff on it? No. What do we use? Pythagorean's theorem. If you know, anytime you know two sides, then you use Pythagorean's theorem, which I've erased most of it up here, but, so we know two sides. First thing we gotta figure out in this one is where is the hypotenuse? Which side is the hypotenuse? It's across, so which one is it? X. So what are we gonna put over here on the right? X squared, right? On the left, what's one of the legs?
140.
So we put, is it just 140?
Radical 40.
It's radical 140, and we got to do what to that? Square. Plus, what's the other leg?
Radical 24.
Radical 24, and we've got to do what with it? Square. What happens when you square radical 140?
Cancels out.
The radical and the 2 just cancels out, and you're left with what? 140 plus 24, same thing there, those just cancel out. Now what do we do? Add them together, what do you get? 164 equals x squared, now what? Take the square root of both sides, you end up with x equals, do we want the decimal form this time?
No.
Probably not, because we start off with radical 140 and radical 24, so we probably want to leave it as a radical form. I would accept on this problem, just radical 164. All right, because their answers weren't broke down any, or the sides weren't broke down any in the first place. Now that might break down. We could go through here and find the numbers that'll divide evenly into that. And I'm going to tell you that 4 will divide evenly into it. Somebody help me out. How many times will 4 go into 164? 41. So I break it into those two numbers. Square root of 4 times square root of 41. What is the square root of 4? So that comes out of the radical. It's just reducing down the radical is what it's doing. And 41 stays in. Either one of those answers I would accept for this problem. This is the simplified answer. That's not. All right, simplified, not. Next question. Number 9. 12-foot ladder is leaning up against the wall. How does the ladder reach up the wall when x is 30 degrees, when x is 60 degrees, or 45 degrees, and when x is 60 degrees. So how many different answers are we gonna have on this problem? 3. So we got this ladder, it's leaning up against the wall. First time they're saying, what if that angle right there is 30 degrees? This is a 12-foot ladder. Well, if that's 30 degrees, that's a right angle. Hopefully, what's this angle up here? 60. In the 30, 60, 90 triangle, what's the side across from the 30-degree angle labeled?
L.
L. Side across from the 60-degree angle?
L radical 3.
L radical 3. Side across from the right angle?
2L.
2L. What equation can we set up there?
2L equals 12.
So what's L?
6.
L equals 6. If L equals 6, we want to know how far up the wall it goes, so we want this distance over here. Well, what is that distance this time? If it's a 30-degree angle? 6. So if it's a 30-degree angle, your first answer is 6 feet. It's going to go up the wall 6 feet. We do it again. This time we'll put a 45-degree angle here. My triangle doesn't look like a 45, 45, 90, but just go with it. We know this side's 12. Side across from the 45-degree angle should be labeled what? L. Side across from the other 45-degree angle? L. Side across from the right angle? L radical 2. What equation can we set up this time? L radical 2, not radical 12, equals 12. How do we solve for L? Divide by radical 2. Now, on the tape measure, when you get a tape measure, you're going to have 12 over radical 2 anywhere on that tape measure. So go ahead and change it to a decimal. What's L end up in? 12 divided by the square root of 2. What is it? 8.5. So 8.5. So we want to know how far up the wall it goes. So what's L? 8.5. So how far up the wall does it go? 8.5 feet. So for a 45-degree angle, it's going to go up there at 8.5 feet. That's our second answer. Then we do the same thing for a 60-degree angle. 60-degree angle there, that's a 90-degree angle, that's 30 degrees. This is 12. Same idea here. We just got done doing this. That's 2L, right? What's L equal? 2L equals 12. What's L equal?
6.
6. All right, so L equals 6. We want the side across from the 60-degree angle, which is supposed to be L radical 3.
6 radical 3.
So 6 radical 3. Somebody multiply that. What's 6 radical 3?
3.5.
3.
No, that's 10.39. Oh, my bad.
10.39.
Yeah.
So 60 degrees. If we had the ladder leaning up there at a 60-degree angle, 10 point, what is it?
3.
10.4 then?
You say 6 divided by 3. Radical 3.
Did I say that?
Yeah.
That's 6 times radical 3, sorry. Which one's going to give us more up the wall?
60 degrees.
The 60-degree angle. So if we make it a 60-degree angle, that makes sense, right? If I lean up here against the wall at a 60-degree angle, I'm going to be farther up the wall than if I lean at a 30-degree angle or at a 45-degree angle. Next question. Are we done? 15. Problem 15. What kind of triangles do we have in problem 15? 45, 45, 90. Let's see. This is Y. This is X. Right away, what do we know X equals then? 45. Because it's one of the angles. So X is 45. That's one of our answers. This side's 13. This side's 13. This side's 13. That's a right angle. This side's 13. In a 45, 45, 90 triangle, the sides across from the 45-degree angle should be labeled what?
L.
L. Let's stop right there for a second. What do we know about L then?
It's 13.
L equals 13. So everywhere we see L, we can stick what in its place?
13.
What's the side across from the right angle supposed to be labeled? L radical 2. What are we going to put in place of L?
13.
13. So what's Y?
13 radical 2.
13 radical 2. 13 times the square root of 2. Do we want to change that one into a decimal?
No.
No reason to, right? That's just a good answer for that problem. Next question. 17. 17, we got 3 radical 5, we got 4 radical 5, and we're looking for that. It's a what? It's a family. Which family?
Radical 5.
This side over here is going to be 5 radical 5. Do we even have to do Pythagorean theorem on that one? And Austin went. Next question.
33.
33. We got a couple more minutes, so we'll be answering questions. Maybe we can squeeze one more in after this one. 33, find the diagonal of a square with perimeter 20. So we got this square. If the perimeter is 20,
You said 33 though. 33
oh, I'm
is the
sorry, that's
perimeter.
32, isn't it?
Yeah.
The perimeter of an equilateral triangle, I apologize. Couldn't read my own numbers. So we got an equilateral triangle, and they tell us the perimeter is 32. If the perimeter is 32, what do we know about each side?
60, 33.
How can you find each side if that's equilateral?
You can
Divide by 3, let's do it.
It's
10 and 2/3. So we know that side's 10 and 2/3. We want to find the height, the altitude, right? Well, when I draw that altitude, what kind of triangle do I have there? 30, 60, 90. In a 30, 60, 90 triangle, side across from the 30-degree angle should be labeled what? L, side across from the 60-degree angle.
3.
L radical 3, that's the part we're looking for, right? Side across from the right angle. 2L. So on this, what are you going to have to do to solve for L? Divide by 2, right? So on your calculator, punch in 10.6666 and just keep pushing sixes, and then hit divided by 2. 5.33. So 5 1/3. So what are we going to put in place of L right here? 5 1/3. That's not really a good way to write anything. 5 1/3 times radical 3. So I would probably accept a decimal answer on this. You already got 5.3 on your calculator, right?
Right.
Just hit times the square root of 3. What's that give us as a decimal?
9.2.
9.2? 9.17? So that's the height. One more, quick one.
Let's do.
Gotta go before it changes to 17. 32? Since I already have this drawn up here. 32, this square right here. They tell us the perimeter is 20. If the perimeter of that square is 20, what do I know about this side?
18. Or wait, 20? 5.
It's 5. How'd you get 5?
Because 5 divided by
Divide by 4, right? So that's 5, that's 5, that's 5. Now I want to find the diagonal. When I draw that diagonal in, what kind of triangle is this? 45, 45, 90. That's a 45, 45, 90 triangle. The sides across from those are labeled L and L. Well, right away we know L is what? 5. L equals 5, right? Side across from the right angle, what's it? L radical 2. What do I put in place of L?
5 radical 2.
What do I put in place of L? Just 5. So how long is that diagonal?
5 radical 2.
5 radical 2. Make sure your names are on those. And pass them over to Evan. Start copying this down.
5 radical 2.
5 radical 2. Trigonometry, doing the trig ratios. Do what?
There's
Is that what you did last time?
I know, I didn't give it to you. I knew you weren't gonna be here Tuesday. have said something earlier then. I thought you had one. I thought you were copying some of the answers down. Took out some of the answers. I thought you, there, you got something now. I thought you had it. Trigonometry, write this down. We're gonna move extremely quickly.
I hate that. Hey.
You know, a lot of these packets and stuff that we're doing now, from here on out, they will be graded.
Starting today?
The packets, yeah. Because I got too many people just writing down stupid answers just to get credit.
On our classes we have, do we have to have to review?
Yeah.
You do?
No, because it said teacher.
No, it said, yeah, they'll take care of
Are
it.
you gonna choose if you're gonna Miss Brown or? Okay.
Hopefully I never.
Yeah, I've already chosen that.
Are we gonna invite in review?
On this, again, make sure you're keeping your notebooks up. Easy grade. I was just making calls and sending emails and stuff. And I looked at one person's grade and I thought, man, if their notebook grade last 9 weeks was like a 40. I thought, man, if they would have just did a notebook, they would have did all right last 9 weeks. This can be stuck right in your notebook. You could write the notes on the back or with this, whatever. We're probably not going to use this ever because you have a calculator. And all of this is programmed into your calculator. Okay? So when we were doing sine, cosine, and tangent, when we did that worksheet after the last test, and you had to punch into your calculator the sine of a 45-degree angle or sine of a 30-degree angle or 12-degree angle or whatever, you could have went right down here on this chart and found that. All they are is ratios. They're setting up ratios, and how does, in a right triangle, how does this side compare to this side? Or how does this side compare to this side? If this triangle has a 28-degree angle in it. Because we know if a right triangle has a 28-degree angle in it, every other right triangle that has a 28-degree angle in it is similar to this one. So we could always set up a proportion. And what the trig ratios have done is they've set up one of the ratios for you already. But they've changed them all into decimals instead of leaving them as fractions. How come they changed them all into decimals? Where did they put them? That's true. Where else? In the calculator. And what's the calculator do? Changes everything into decimal. All right, write this down. Sine, cosine, and tangent, and then write those 9 letters with space in between them. So, because we're going to add something to this slide.
How do they spell sine? Spell it like an actual sine.
SOHCAHTOA.
My
These-
sister was telling me about this.
These are the kind of things that I dislike. This is like the PEMDAS and all that stuff some elementary school teacher comes up with and to try to help you memorize stuff. And it's very, very helpful, I know. So that's why I'm going over it. But I just dislike them because sometimes I think that's like a crutch that you're leaning on instead of just memorizing something. All right? The first part, the SO part, S-O-H. What the S-O-H means, and we'll talk about this as we go. If you're in a triangle, if you have a triangle, and we want to deal with this angle right here, what we're going to do is we're going to label this triangle accordingly, according to that angle. Remember on the other stuff we did, we labeled it like L, L, and L radical 2. Now we're going to label it with actual names. If we're dealing with angle A right here, this angle, or I'm sorry, this side over here is going to be called the opposite leg.
Can you just draw that?
Yeah, that's up to you. The side across from the right angle, what's it always called? The hypotenuse. And the side that's actually hooked to the angle that we're dealing with, that's not the hypotenuse, it's called the adjacent leg. What's adjacent mean again? Next to or hooked to. Adjacent leg. So we got an opposite leg, that's the one across from the angle that we want to deal with, an adjacent leg, and the hypotenuse. And that's what these letters sort of stand for, some of them, and we're going to write them down right now. This is the part for sure you need to write down. The S, the first S here stands for sine. So you write sine right underneath that. Anybody have a guess what the O stands for? Opposite leg. Opposite leg. Each one of these is a fraction. So this is saying the sine is the opposite leg over, what do you think H stands for? Hypotenuse. Hypotenuse. So that's the sine part, that's the so part. Sine is always opposite leg over hypotenuse. Opposite leg over hypotenuse. And you guess what the C, you could probably fill out the rest of this on your own. And you guess what the C stands for? Cosine. How about the A? Adjacent leg. Adjacent leg. How about the H? Hypotenuse. Hypotenuse. It's hard to spell things up. So the cosine of an angle is always going to equal, so the cosine of angle A is always going to equal the adjacent leg on top and the hypotenuse on bottom. Those two numbers, that ratio. What do you think the TOA part is? Tangent. Opposite leg. Over adjacent leg.
And funny as I like write the things down, like it started out so straight and then my mind just started doing this. As I wrote it, I was like, what?
Now, when you get to Mr. A's class, there'll be other trig ratios also, but these are the three we're going to deal with. These are the three main ones. Everything else is based off of these three. So we got the sine, which is opposite leg over hypotenuse. Cosine is adjacent leg over hypotenuse. Tangent is opposite leg over adjacent leg. Just setting up, matching them up. This number over this number. SOHCAHTOA. Alright, that's just something I found. So sine opposite over hypotenuse. This is always going to be a fraction right here. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. It's always going to be a fraction. It's a ratio.
You want us to write that down?
No, this I want you to write down. This is the way it's going to look mathematically. Instead of SOHCAHTOA, sine angle A equals whatever the opposite leg is over the hypotenuse. So this is what we're going to do. We're going to set up equations. Sine angle A equals something over something. Cosine angle A equals something over something. Tangent equals something over something. First thing you got to do is pick the angle that you want to deal with. And we're going to talk about that here in a minute. The angle you're never going to pick the right angle. It's always got to be one of the other two angles. If you look on that chart I gave you, there is no right angle on there, I don't think. I don't think there's no 90 degrees.
There actually is.
Is there?
Very
Not
close.
supposed to. But it's got blanks or something, doesn't it?
Yeah.
Sometimes the chart has it, sometimes it'll have 90, sometimes it'll just stop at 89.
The very last one.
Yep, so it goes 1, 0, and then it's got an infinity symbol. We're not going to ever deal with that. So if they ask you to find the sine of angle A, all you're going to do, put the number that's the opposite leg over the number that's the hypotenuse. If they actually ask you to find angle A, we're going to do something with that too. So this is how mathematically we're going to represent these. Notice every time you got an equation, each one of these is an equation. And we're going to set up those equations, and there's going to be part of it missing. Maybe one time the angle's missing, and we know these two things. So we're going to use that and solve it to find that angle. Maybe the next time the opposite leg's missing, we don't know that length. And we're going to use it and find that opposite leg. Maybe the next time the hypotenuse is missing, and we know the opposite leg and we know the angle. And we're going to set up an equation and use it to solve. Don't make these harder than they are. Your calculator is going to do a whole lot of the work for you.
Will there ever be anything where they're like, you're missing the same cosine?
Yeah, if you're not, you won't be missing the sine or whatever. You'll have to decide which one am I using, sine, cosine, or tangent. All right? You might be missing the angle though that you want. But if we know these two, we can find that angle, and I'm going to show you how on your calculator.
I feel like you're gonna teach us all this, and then like, then we do spring break, and then as soon as we come back, we're gonna be like, quiz
Yep.
time, and we're like, ah!
That's very possible. So the first thing you're going to do every single time, the very same as with the 45, 45, 90, and the 30, 60, 90. First thing you're going to do is label it. So if I want to deal with angle A right here, I'm not dealing with angle B, I'm dealing with angle A. What I'm going to do, I'm going to label it this way. First thing, I draw in an arrow. Everybody knows how much I like to draw arrows, right?
Yep.
I draw in that arrow, and that arrow's pointing at this side. What are we going to label that side? The opposite leg. So that's the opposite leg. Every single time you pick the angle, and then you label the sides accordingly. Once we know where the opposite leg is, then I draw in another arrow. Why did I draw that arrow? To tell me where what is? The hypotenuse. I label that side the hypotenuse. Does it matter which angle we're dealing with for the hypotenuse? No, it's always across from the right angle. It's not going to change. Once I label the opposite leg and the hypotenuse, the one everybody has the most trouble with is the adjacent leg. How many more sides do we have? One. So what's it got to be labeled? The adjacent leg. It can't be labeled anything else. Notice it's the leg that's hooked to angle A. This leg is not hooked to angle A. This one is. That's the adjacent leg. What if we were dealing with angle B instead of angle A? What would change there?
Adjacent leg,
What would it change to?
or the opposite leg.
That'd be opposite, and then the opposite leg down here would now be the adjacent leg. So if we're dealing with angle B, all that's going to change, my pen would work, is those two flip where they're at. The opposite leg and the adjacent leg switch their positions. So if I told you, we had a triangle, we had a family of triangles that was 5, 12, anybody remember this one?
15? Is that close?
That was the 8, 15, 17 that you're thinking of.
Is it in the 20s?
Nope, it's lower.
14.
5, 12, 13. I'm hoping you remember some of those because it's going to be, look back at them because it's going to be helpful. If I wanted to deal with this, if that was angle A, and we wanted to find the sine of angle A, sine of angle A. Our SOHCAHTOA for sine, the so part says what over what? Opposite over hypotenuse. So we want to figure out, and we want to label this, hey, this is the opposite leg, that's the hypotenuse, that's the adjacent leg. For sine, we want opposite over hypotenuse. So what's the number for the opposite leg? 12. What's the number for the hypotenuse? That's the sine of angle A. We don't need, not to do that. We really didn't need anything. Now, if we wanted to find angle A, that's when we'd start using the calculator. All right? But just to find the sine of it, that's all we did. What if we wanted the cosine of angle A? What's cosine? That's the C part, C-A-H. Adjacent over hypotenuse. What's the adjacent this time? 5. What's the hypotenuse? 13. That's the cosine of that angle. Do we know what angle A is? No, but we know that the cosine of it is 5 over 13. How about the tangent? Opposite over adjacent? Is that right? So what's the opposite? 12 over 5. All right? Notice, 12 over 5 is bigger than what? It's bigger than 1, right? It's bigger than a whole. The others won't ever be that way, and we're going to write that down here in a minute on another slide. The sine and cosine, if you come up with the sine of something is 3.5, you did something wrong. But if you look on this chart, look down through the signs never ever get bigger than if we don't go to 90, never gets bigger than 0.999 something something. Cosine the same way. Now the tangent though, on this chart, it goes clear up to like 57. So the tangent can be anything, any number. Sine and cosine always have to be less than 1. So it always has to be a decimal.
It's got a 0 degree angle on the chart too.
Yeah. So I should have probably came up with a different chart. All right, to find sine, cosine, and tangent, that's what we did. That's what I was just doing. Can I write this down? This is this top part. This is just if we want a fraction answer. If we're given the triangle and we want to put like 5 over 12 like we just got done doing. This is if we know the angle and we just want to use our calculator and find the decimal answer. Those are the steps that you use. The top one's what we just got, the first 3 steps up here is what we just got done doing. I'm not sure why I labeled the top steps 1, 2, 3, and then the second one I put 1, and then A, B, and C. I don't know, because I'm not an English person, I guess. I don't know how to outline things. Miss Gray would have a field day trying to grade any of my English stuff.
Well, isn't it set up so you understand it?
Do up, yeah, it's that.
Yeah, you set it up so you understand it.
Miss Kelsey's class.
We're not trying
Read
to.
it, Mr. Lee.
I miss her.
I miss Miss Conrad.
I never had her. I miss her.
All I read was Mario.
I miss her. I miss Kelsey. I think the best one in her class was moved up in Bridges. Yeah, but it wasn't as hard as Miss Kelsey.
So this is what we were just doing on that other slide. You label it opposite, adjacent, hypotenuse. Notice, am I ever going to write out opposite leg, adjacent leg, abbreviate it, make it easy on yourself. All right? Write the ratio, something over something, 5 over 13, 5 over 12, whatever it was that we just did on that last power, or on the last slide. If you know the measure, then you can just use your calculator, or you could use the chart. Probably don't want to use chart, probably want to use calculator, so make sure you have your calculator each day. And all you do, punch in sine, cosine, or tangent, the angle measured, then equals. Now this doesn't work if you have one of the calculators that doesn't print across the screen, then you got to do it a different way. You got to do it backwards. So you'll have to punch in the angle measure, then hit sine, cosine, or tangent.
These ones print out, I take it.
Those would work to do this. So, Evan, on yours, since you got that calculator,
Yeah, I did backwards.
you might just put arrows there and flip A and B around. You might not even have to hit equals. It might just pop up right after you hit the sine, cosine, or
So, like,
tangent.
30 then.
So, yeah, put in, let's do one that's, well, nah, it's not easy for you. Let's do something other than 30. Don't do 30 because that might confuse you. Do like 58,
Which one?
sine. Did it pop up right after you hit sine?
It's like 0.8.
Okay, so you don't have to hit equals, do you? See, on the other calculators,
Yeah, I do.
all digit.
Yeah. Yeah, no, I did.
So we label this is what we were just doing on the other slide. I'm gonna skip through that pretty quick. If we were dealing with angle B, if we're dealing with this angle, we already talked about what switches. Opposite and adjacent leg, they just switch places if you're dealing with the other angle. What happens if we're dealing with angle C? Nothing, because we don't ever deal with the right angle. Remember me saying that a few minutes ago. Don't deal with the right angle. Don't label the triangle according to the right angle. The only thing that gets labeled according to the right angle is the hypotenuse. We just got done doing this one. Somebody tell me how long is this side right here? 5. All right? If that side's 5, that's 12, that's 13. If we want to find the sine of angle A, cosine of angle A, and the tangent of angle A, then we label the triangle. That side's going to be your opposite leg. That's your hypotenuse. This side over here then is your adjacent leg. Sine, the so part, deals with which two of those? Opposite over hypotenuse. So what is that? 12 over 13. The cosine is the co part, 5 over 13. And the tangent is opposite over adjacent, the TOA part, 12 over 5. If that's all they want you to do, you just leave it that way. That's your answer. What's the sine of angle A? 12 over 13. That's your ratio. All right, we're going to do more with it than that, but sometimes they'll ask you just to find the sine, and if that's the case, you just write that down. You don't have to grab it and change it to a decimal. You don't have to do anything else. What's going to change when we find angle B? This is the opposite leg now, and this one down here is the adjacent, and now this is the what? Still the hypotenuse. And then we just switch it around. Let's just write it real quick.
13.
5 over 13. About for cosine.
Over 13.
12 over 13. The tangent, the TOA part.
5 over 12.
5 over 12. Does anybody know what happened with those from the last slide?
They flip.
Look at these. Memorize all 3 of those. Now I'll go back.
Oh, they switched.
The sine and the cosine switched, and what happened to the tangent? It was a reciprocal, it flipped over. So whenever you're dealing with angle A and then angle B in the same triangle, the two acute angles in the same triangle, that's what's going to happen. Things to remember, write this down. Sine and cosine are always, what's this alligator mouse say? Less than 1. You might want to write out the words less than 1 if you're not sure what that alligator mouth is.
Oh, it's been so long. I've been like 4th grade since I've used one of those.
Mr. A uses his all the time. Not all the time, but quite often. The tangent can be any number. It can be 0.2765, so it can be less than 1. It can also be 13.582. It can be more than 1. Sine and cosine, though, if you come up with a sine and it's 3.4762, it's wrong. All right? The other thing, I'm going to maybe write something down on here. Always go out 4 decimal places. Always go out 4 decimal places. Not sure why, but somebody a long time ago decided when you're dealing with sine, cosine, and tangent that you always want to go out 4 places behind the decimal. Tenths, hundredths, thousandths, 10,000ths. So we're going out to the 10,000ths place. All right, to find an angle, these are the steps to find an angle. Write that down. I'll give you a minute to write that down. This is using your calculator. I know none of you want to use the calculator to find the angle. You probably want to use the chart. And then I think on yours, I think you put this in. I think number 5 comes up to number 3. Okay, and then the rest of them drop down. That's it. Yeah. Notice, what did I write in red there?
Label triangle.
Gotta label the triangle first every single time. If I didn't beat that into your head enough with 30, 60, 90, and the 45, 45, 90 triangles, then we're gonna do it some more, because that's what you gotta do every single time. You know, round your answer off. Round off, the book might tell you to round off to the nearest tenth or something when you're finding an angle. If it doesn't specify for angles, always round off to the nearest degree. So like 25 degrees, or 32 degrees, or 17 degrees. The old books used to round every angle off to the nearest whole number. I'm not sure on this new book, it seems to like to round everything to the nearest tenth. So it might want to go out 1 place behind the decimal. So let's try one of these. We got a triangle. Let's do give me one of the families. We'll just use one of them. 3, 4, 5, that's the easiest one, right? So if I got this triangle, this side's 3, this side's 4, what's this side? 5. We don't know what this angle is. We'll call that angle A. We'll call this angle B. Let's find angle A first. First thing we're going to do is set up an equation. So we got to decide if we want to use sine, cosine, or tangent. Since we know all 3 parts, does it really matter which one we use?
No.
So we'll set up 2 of them, and half of you do one, half of you do the other. See if we get the same answer. First thing I got to do is label this. What's that going to be labeled? Opposite leg. What's that side going to be labeled? Hypotenuse. And what's the 4 going to be labeled? Adjacent leg. Alright? So let's do sine and cosine. So we want sine of angle A, cosine of angle A. And half of you is going to do one, half of you is going to do the other. Sine of angle A. Sine deals with which 2 parts?
Opposite.
Opposite and hypotenuse. So what is the opposite?
3 and 5.
3 over 5. We'll come back to that here in a second. Cosine deals with which 2 parts?
Adjacent and hypotenuse.
Adjacent over hypotenuse. So 4 over 5. All you're going to do on your calculator, if I'm doing the sine one, I'm going to show you how to punch it in, but I'm not going to finish it. On the sine one, you're going to do, we've already set up the equation. You're going to push second, sine, what comes up? See sine -1, that means you're telling the calculator to use the chart, but use the chart backwards and find the angle. Instead of knowing the angle and finding the sine, We know the sign and we're gonna find the angle. We're going backwards. So you hit second sign and then you punch in your fraction. You can just punch it in right like a fraction. 3 divided by 5. All right? What are you going to do if it's the cosine? Second cosine, and instead of 3 divided by 5, it's going to be, so half of you do one, half of you do the other, and tell me what it tells you here in a second. And what you're doing here is you're finding angle A. You're finding that angle.
I'm confused
I'm
with
very
this one. Like, I get that one, but I don't know this. I got that confused.
So just, all you're doing, you're going to put in the fraction first.
Oh, okay.
3 divided by 5, and then you're going to hit what? Second sign, or second, whichever one you use. Anybody get angle A? What's the measure of angle A if you use sine?
36.9.
36.9, so about 37 degrees. Anybody get that? Do the cosine one. 37 degrees. Should angle A come up to be the same both ways? Yeah.
Yep.
Should come up exactly the same both ways.
I thought sine and cosine are always less than 1.
They are, but the angle's not. This is
Oh, I
3
see.
over 5 is
Okay.
the sine, and that's less than 1. 4 over 5 is the cosine.
I
That's,
was, yeah, okay.
so you're actually finding the angle, all right? So we know that this angle is 37 degrees. Somebody help me out. Tell me what angle B would be without using sine, cosine, or tangent. How could you find angle B? 3 angles of a triangle must add up to 180. What's 90 plus 37? Subtract that from 180. Do that real quick.
He's 53.
53, everybody agree with that? So that angle's 53. Let's use sine, cosine, and tangent and see if we come up with 53. Let's use tangent this time since we haven't used it. We got to change this. We're now dealing with angle B instead of angle A. What's this side going to become?
Adjacent.
Adjacent. What's this side going to become?
Opposite.
Opposite. The TOA part, the tangent part, we set up our equation. Tangent, angle B, you're always going to set up this equation. Tangent, angle B equals something over something. The TOA part is O and A, so opposite over, so what is it?
4 over 3.
4 over 3. So in your calculator, you hit second. What are we going to hit for this? Tangent. 4 divided by 3. Close the parenthesis if you have a parenthesis on your calculator.
Does it matter if you close the parentheses?
Sometimes it doesn't, but 53.1. What's that round off to? Is that what we said that angle should be?
Yep.
So if you're looking for an angle, you do these steps. The main part that everybody's going to have trouble with, and the thing that you're going to have to do on all these problems, you got to set up an equation. Sine of angle equals something over something. Every single time we're going to set up one of those equations. Whether we're looking for an angle or we're looking for a side, you're going to set up that equation every time. Some equation. Now I say that equation. Does it always got to be the sine? Might be the cosine. Might be the tangent. That's just the calculator. I'm going to use it. That's the other calculator. Just sine, cosine, and tangent buttons. Notice above them, whenever you see that sine -1, that means you're doing it backwards. You're finding the angle instead of finding a part, a side.
So what happens if you just do sine? Like,
So-
what would you find in that case?
So if we went sine angle A equals 3 over 5, and we just punched in, we hit sine 3 over 5, what you'd be finding is you'd be finding the sine of an angle that's 3/5 degrees.
Oh. Okay.
And we don't want that, because we're probably not going to deal with an angle that's 3/5 degrees.
Right.
We just did that. All right, write this down. Kobe. Angle of elevation. When you start looking like Kobe, I'll let you shoot it.
First of all, Mike.
That's, might be a major problem then. Angle of elevation, angle of depression. Easiest way to remember this, if I'm standing here and I look up at the ceiling tile right there, my eyesight was here, now it's here. Is that an angle of elevation or an angle of depression? Elevation, because I went up. Now, I'm standing here and I look down. I look down at that ant crawling across the floor.
Angle depression.
Angle of depression.
You look down because you're depressed.
Right.
I think
Down, depressed. If you can remember it that way, then use it. Something like this one with my little stick person here. Look, I gave him arms. Everybody's always complaining I'll never give him arms. It's like he's standing on a cliff looking down at the boat. Angle of depression. Angle of elevation. My eyeball right here. Looking up at that bird. Why might we be covering these things right now? Because when I draw that in, what kind of triangle do we have?
right
A right triangle. And anytime we have a right triangle, we can use sine, cosine, and tangent. What kind of triangle do we have down here? Right triangle again. All this stuff dealing with right triangles. Everything, just about everything we've done this chapter has dealt with right triangles. Sine, cosine, and tangent. Yeah, sorry. I was got confused why I titled it the way I titled it. Oh, I know why I titled it that way.
There's 66 questions.
I know, and we got about 20-some minutes, and we're gonna try to do a whole bunch of them. If we're doing a problem, and we know this side is 7, maybe. We know this angle up here is 25 degrees, who knows? That's all the information we need to know, and we can find every other part in this triangle, right? First, how would I find this other angle?
You could add it and subtract it.
Add those two up, subtract from 180, you could find the other angle, right? I can find one of these two sides, whichever one I might want to find. It doesn't really matter which one in this case, because I didn't tell you what we're doing. I can find one of those by using SOHCAHTOA, sine, cosine, or tangent, all right? Once I use sine, cosine, or tangent to find, let's say, that side. Let's say we figure out that this side right here is 9.2. How could I figure out that third side over there? Could I use sine, cosine, or tangent again? Yeah. It's not like you can only use it once and then you're done, all right? That's all it works. What's the other way I could find it? Using what? Pythagorean's theorem. If you know two sides of a triangle and you're looking for the third side, probably the easiest way is to use Pythagorean's theorem. All right, so once you find this side, if you know two of the sides, use Pythagorean's theorem to find the third side. Make it easy on yourself. Unless you like sine, cosine, and tangent. I like sine, cosine, tangent, and I think that they're easier than using Pythagorean's theorem.
How
So
would
that's
we
up to you.
use sine, cosine, tangent to find a side though?
I'm getting ready to show you that when we do some of these problems.
Number 1.
On this worksheet, first, like problems 1 through 12, I don't want to do a whole lot of these 1 through 12s, but I have this bad feeling that as soon as I show you how to do one of them, you're going to ignore me and just try to do them real quick.
True.
All right? So we're going to do a couple of them, then we're going to skip that section. You go back to it because they're very simple. All right? Is everybody okay with that? So number 1, how am I going to find the sine of a 12-degree angle? All I do is I take my calculator and I punch in sine 12, close my parenthesis, and I hit equals, or enter. That's my answer.
What you put a second?
Nope, because all we're doing is finding the
I'll do
sine.
it back to 12.
So then, what would you round to?
What do we round to? How many spaces did we say go out?
4.
4 spaces, so tell me what I'd write down.
0.2079.
0.2079, that's the answer to number 1. Do number 2 and tell me what you get. Slow down, I didn't get it yet. What is it?
0.9702.
Close.
Oh, 3.
03, round it up, because there's a 9 back here. So 0.9703. Does everybody understand how to do that section? That's pretty easy, right? You might write out to the side there, calculator. Just use a calculator.
Do you have to do parentheses?
Huh? You don't have to. Is everybody getting the same answers that I was getting up here?
Yeah.
Because if you're not getting the same answers, we gotta fix your calculator. Because it's not set on degrees or whatever. Look at the second one. Look at the second section. We'll do more of these. We're doing the first section. See, I knew this would happen. I shouldn't even ever show you how to do the first section, should I? Because those are easy. Those are the ones you want to do on your own, right? The second section, we're actually going to find the angle. We're actually going to find the angle. So now, some of you said this a second ago. Now what do you got to hit first?
Second.
Second. Now is when you're going to hit second. So on the very first one, I'm going to punch in second cosine. Notice when it's second, that tells me I'm looking for the angle. It's got a -1, and I punch in, I'm going to hit second again because I want the square root of, what is it, square root of 3 divided by 2. And this time, this is where the parentheses are messed up. On my old calculator, it's one way. On the new calculator, it's a different way. You got to make sure, see I got 2 parentheses here? I do have to close those, otherwise the calculator is not going to understand it. So I'm going to close that one, and then I'm going to close the other one. So I got a double parenthesis there at the end.
And you wouldn't put a parenthesis around the 3? to,
No,
like, make
because
it-
this is just,
Or would that be a square root?
oh, I did close it wrong, didn't I? Daggone it. So I should have closed it there.
Okay.
And then hit divided by 2, thank you. And then the parenthesis. Now it makes sense, doesn't it?
Mine's different, because like if I hit square root, it does it the right way.
Alright, so what you might have to do is you're gonna hit square root of 3 divided by 2, then hit second cosine.
You're 30.
I did too. That's in degrees, right?
Yeah, 30 degrees. So what's the measure of angle X there?
30.
30 degrees.
Okay.
Try 14. So we do sine. Nope, we don't do sine, sorry. We do second sine. What's 1/2 as a decimal? 0.5, so we could just punch in 0.5, 30 degrees. How about 15? Anybody get 15?
45.
45, everybody agree with that? 16, what would we hit on 16 that's a little different?
You put the decimal in.
Just put the decimal in. So we do second sine, put that decimal in, 0.6258, probably just some crazy decimal that I just randomly made up. 38.7, so we probably round it to 39 degrees.
Okay.
All right. Flip over to the second page. Again, I think those are pretty easy because it's all your calculator, right? On the second page, these are the ones that are going to be a little harder. Let's look at problem 28. These are the ones where you're actually finding a part of the triangle, whether you're finding an angle or you're finding the side. Watch closely on these and make sure you understand. I'm going to try to do 2 or 3 in the next 15 minutes before you leave to make sure you understand it. We know this is X, this is 28. You guys help me, because I can't see the numbers very well. That's 32, right?
Yeah.
Which angle do you think we're dealing with in this case?
The
angle,
adjacent.
the 28. We're dealing with this angle. How do you know which angle you're dealing with? Because it's the one they told you. All right? That's what we want. So we want to label this triangle according to that angle. Does everybody understand that part? That seems to, getting started is probably the hardest thing. That angle, how come we're dealing with the 28-degree angle? Because that's the one they told us. Do we want to find this angle and deal with it?
No.
No, they didn't ask us to do all that. That's extra work. All right? Now, does that make sense, honey? Now I'm going to label this triangle accordingly. What's that side going to be labeled?
Opposite.
Opposite leg. That's the opposite. What's this side going to be labeled? Hypotenuse. What's this side going to be labeled?
Adjacent.
Adjacent. Here's the second thing where everybody's going to struggle. How do I know if I'm using sine, cosine, or tangent? All right? You got to be able to make this decision. The reason that we know we're going to be using sine, cosine, or tangent
It's the opposite side.
is what we're looking at or what we're looking for and what they told us. Did they tell us anything about this one over here? Are we trying to find that one over there? So what I usually do, I mark that out. We don't want to deal with the hypotenuse because they didn't ask us about it. They didn't tell us about it. We want nothing to do with it. Then we look at this. Which trig ratio deals with opposite and adjacent? Tangent. So which trig ratio are we going to use? So we set up that equation. Tangent of, what's our angle? 28 equals what over what?
Would be X over 32.
X opposite over 32. And I'm going to write this down over here. You might want to put this, when you're setting up the equation, you might want to put this in your notes every time. You're going to put the trig ratio, whichever one you're using, sine, cosine, or tangent. Then you're going to put the angle. Then you're going to put an equal sign. Then you're going to put a fraction bar with whatever on top and whatever on bottom. Every time you're setting this up, it's going to be that same thing. Are we always going to know the angle? No, sometimes we'll be looking for it. Are we always going to know this number that goes here? No, that might be X. Are we always going to know this number? We can pick the trig ratio. We got to pick that ourselves. We got to make that decision. But the angle, these are where our, maybe an X is going to go here, maybe it's going to go there, maybe it's going to go there. And that's what we have to decide when we're setting up these. Our X this time is here. So this is if we're looking for a side. First thing you're going to do to solve this, grab your calculator and find the tangent of 28 degrees.
88.
What is it?
And you have 28? 88.
88.
No,
27.
45.
Oh, I thought we were just doing it.
Tangent, you guys are hitting second.
Yeah.
Oh, okay, I hit second.
Yeah.
Don't hit second. We know what the angle is.
0.5.
0.5.
317.
317 equals, and we're just going to leave this part over here the same for now, X over 32. All right? Brianna, you can handle all that? Now, what I'm going to do, and this is just because I'm lazy and this, I think it makes it easier on me. Maybe it won't make it easier on you. I put a 1 underneath that. How come I put a 1 under?
Make it a fraction.
Make it a fraction. Now we have the whole thing is called a what? Proportion.
Oh, yeah.
And we've been doing proportions for the last 2 chapters, right? And what do we do to solve a proportion? Cross multiply. What's that way give me?
1x.
1x or x. What's this way give me?
17.01.
How long is that side x in?
17.
Do another one.
Yeah.
Everybody got 28 before I erase it? Pick me another one down to there. 35. $35. This is x. This is 17. What kind of triangle do we have here? 30, 60, 90. In a 30, 60, 90 triangle, could we find x without using sine, cosine, or tangent? Yeah, but this time we're gonna use sine, cosine, or tangent. Which angle are we gonna deal with? Which angle? The 60. How come the 60? It's the one they told us, right? What's that side gonna be labeled? Opposite. What's this side labeled? Hypotenuse. What's this side labeled? Adjacent. Which one don't we care about this time? The adjacent. Get rid of it. We don't need it. Which trig ratio deals with opposite and hypotenuse? Look at your SOHCAHTOA. Sine. So we're going to do the sine. We write down our trig ratio. What comes next? The angle. What is our angle?
60.
Equals the SO part. SOH. What over what?
X over 17.
All right, opposite over hypotenuse, so Evan's saying the opposite side is x, the hypotenuse is 17. We set up that equation every time. Some equation like that. What's the next thing we do?
Get the sine of 60.
Find the sine of 60.
8, 6, 6, 0.
Don't change the other side. Now what do we do?
Over 1.
Put that over 1, cross multiply, what do we get there?
14.7.
X going that way. Now, the two that you guys, the one that I picked and the one you picked, worked out where we cross multiply here and you just got X. Sometimes you may have to divide to finish solving. This time and the last time we didn't have to. What do you get when you cross multiply this way?
14.7.
How long is that side right there in that triangle then?
14.7.
14.7. Somebody do this for me. This side in a 30, 60, 90 triangle, this side would have been 2L, so 2L equals 17. That means L equals 8.5. Side across from the 60-degree angle should have been L times the square root of 3. Well, L is 8.5. So if we were doing this problem on the last time's assignment, it would have been 8.5 times radical 3. On your calculator, somebody help me out.
14.7.
14.7. Exact same thing that we just got. Either way, we're going to get the same answer. It's not going to change because you do it one way or the other.
So if we don't want to do this, I can do it that way.
On that one you could have because it happened to be a 30, 60, 90 triangle. But does that work on every one of these?
So
No.
essentially like solving all this is the same exact thing, it's just in a different way.
What about on the 45, 45, 90?
Right. So if you see a 45, 45, 90 triangle on here, you could use it. Right? 38 is a 45, 45, 90, isn't it? Somebody tell me what x is without going through all this sine, cosine, and tangent.
Which one?
38.
18?
18 radical 2.
Oh, okay.
18 radical 2 would be the answer there. All right? Because we use the, yeah, you could give me the decimal answer too. 18 times radical 2, whatever it is.
So we could just write that down now?
Yep.
Okay.
Pick me another one. Let's do one that's got an angle that we're looking for.
On this page?
Yep.
32.
32, I heard. 32. This time we're looking for an angle. We're looking for that angle right there. It's x degrees. This is 39. That's a right angle. This is 44. Probably the last one that will, 12:16, is that what time? Or 12:18?
18.
We might have time to do a couple. So we got this. Which angle are we dealing with?
The X.
The X one. So we got to label a triangle accordingly. What's that side going to be labeled?
Opposite.
Opposite. What's that side labeled? Hypotenuse. What's this side? Which side do we not care about? We don't care about the adjacent this time. Has it been the adjacent every time that we haven't cared about?
No.
No, not a person.
Oh, the first one was the hypotenuse one. Okay. So now we got this. Which trig ratio deals with opposite and hypotenuse?
Sine.
Sine. So we're going to do the sine of our angle. What's our angle this time?
X.
X. We don't know it. So it's x degrees equals opposite over hypotenuse. What's the opposite this time?
44.
39 over 44. Once you set up this equation, doesn't this look like the problems we did back on the first page? All you're going to do, we got to do second because we're actually looking for an angle. Anytime you're looking for an angle, you're going to have to use second. So we hit second, then what? What do you hit after second?
What?
Sine, And then we punch in 39 divided by 44.
62.4.
62.4.
So 62.
So there's 62. So what's that angle right there?
62 degrees.
62 degrees. 62 degrees. Could we find this angle once we knew that that one's 62?
Yeah.
How?
90 plus 62.
Subtract from
28.
180,
28 degrees.
28 degrees. So now we know that angle. How could we find this adjacent side over here even though we marked it out and said we didn't want to find it? Do we want to go through all that sine, cosine, tangent stuff?
Use the Pythagorean
Could just use Pythagorean theorem. Which one's the hypotenuse?
44.
44, so that goes on this side all by itself. Then what's on this side? 39 squared plus b squared. We solved that. Now, do we know every part of the triangle? Know all the sides, know all the angles once we find that. Next question. Find me that little 8 there. 45? It's way over there. Problem 45. Use the inverse trig. Again, we're finding the angle this time. So same as that last problem. We're finding x, that angle right there. Anybody tell me what this side is, even though we don't care about it?
Yes.
Tell me what number.
Oh.
5.
5.
Yeah.
We really don't care about it, but it's 5, 12, 13. Now tell me what it's going to be labeled.
Opposite.
Opposite. What's this side going to be labeled? Hypotenuse. Adjacent. Now, since we do know all three sides now, does it matter which trig ratio we use?
Nope.
No, we could use any of them. So pick me one. Sine, cosine, or tangent.
Sine.
Sine. Sine of, what's our angle this time?
X.
Sine x equals, sine is the so part, opposite over hypotenuse. What's the
5
opposite?
over 12. 13.
5
13.
over 13. What are you going to punch into your calculator?
Second.
Second sine, 5 divided by 13,
22.61.
so about 23 degrees.
Ready to pull back it?
Yeah, try most of it. We'll do something with it next time to put some effort into it. Don't come in here with none of it tried, otherwise that's going to make me think, hey, I should just play.
We can start asking tomorrow. Like
For a side in the triangle.
34.
34. On 34, watch and make sure these are going to be the hard ones. All right? So you got to make sure you're watching and paying attention. Everybody, Michael's joking around a whole bunch. Right now is when it gets rough. And if you don't pay attention right now, just like with the 30, 60, 90 and the 45, 45, 90, you will be lost. And I'm not going to recover this like I did with that stuff. So 34. Terrible. I got this right triangle. Just
That's a beautiful triangle.
go with my triangle. It's 59 degrees there. That's x. That's 17. How do I know I'm not using like 45, 45, 90 stuff?
Well, you got 59.
Because you got a 59 degree angle, so you can't use that. Now, and I'm going to tell you the spots where most people, most students get hung up on the most. All right? The very first thing is, I don't know where to start. You start by using the angle that they tell you. How come I don't want to use this angle? You don't know it. You never, ever, ever use the 90 degree angle. Does everybody understand that? Never.
You can easily find the other angle.
All right, you could find the other angle, but do we want to do that work to find the other angle if they've already told us one and that's all we need?
No, because we're looking for
Not
an
really.
X, we're not looking for another angle.
So we're using that. Next thing we do is we label the triangle. What's that side going to be labeled? Opposite. So write in opposite right there. Should be doing this on your paper. What's that side called? Hypotenuse. Every time you got to label this. What's this side called? The next thing, the next part that most people get stuck on is they don't know which trig ratio, sine, cosine, or tangent to use.
this one would be sine.
What you do, the way you decide what to use is number one, we look at the sides. Which side do we care absolutely nothing about? The adjacent this time. They didn't tell us the adjacent, we're not looking for the adjacent, so I mark it out.
We only care for the opposite and hypotenuse.
Opposite and hypotenuse. Which trig ratio in the SOHCAHTOA deals with opposite and hypotenuse? Sine. So that tells us we're going to use the sine ratio. So we do the sine. Remember, we write down the trig ratio, then the angle, then an equal sign, then the fraction bar. All right? So our trig ratio is sine. What's the angle this time? 59 degrees. Equals, then we put in our ratio. What's our ratio? Opposite over hypotenuse. X over 17. That's our equation. So now we've written our equation. And what we're going to do is solve that equation. Okay? Next thing we do. I know this seems like it takes forever. Once you do a couple of them, they won't take anywhere near this long. Next thing you do is you take your calculator and you find, we want to get rid of words. You can't solve an equation if it's got words in it. So we want to get rid of it. So you take your calculator and you find the sine of 59 degrees. How do I punch that into the calculator? Sine 59. Don't hit second. We already know the angle. So sine 59. What do you come up with? Remember, we want to go out how many places?
0.9571.
You understood all that, right?
0.9571.
8, 5, what?
7, 2.
7, 2. Everybody agree with that?
What do we change
Times it. Actually, just times the number you got by.
You only round
17.
off the last one. All right? No, Mark, we're not doing that. So now, I got that equals, and I still got x over 17 on the other side. Now, this is what you do. We haven't solved anything yet. We don't know what x equals yet. Every single time, and some of those of you who did this last year, Mr. Harrison might have taught you a completely different way. I don't know. Every time, I put a 1 under that number right there. Did he teach you that way? You know why he taught you that way?
Why?
Because I taught it to him.
So it's like proportion now?
You put a 1 under it. Now it's a proportion, and everybody seems to know how to solve proportions. What do I get when I cross multiply this way?
1x.
1x or just x? What do I get when I multiply that way?
14.6.
Round it off to the nearest 10. 14.6. Guess how long that side right there is? 14.6. Pick me one on that same page where we're looking for an angle.
38.
An angle. 32?
31.
32. Problem 32, we're looking for an angle. If that confused you, we'll do another one here in a minute. We'll do as many as we can till 2:30. Problem 32, this time we're looking for an angle. We got this triangle, looks something like this, that's x. This is 39, that's a right angle, that's 44. Which angle are we going to deal with? This one, or this one? The x. All right, never the right angle, that one we don't know and we don't care about, so we're not going to deal with it. What's that side called? Opposite. You still got to label it. What's this side called? Hypotenuse. What's this side called? Adjacent. Which one of those do we care absolutely nothing about? Adjacent again. I don't know why it's always adjacent, but it's not always adjacent. It's just happened to be on the ones that we pick. Now we're going to set up our equation. Which trig ratio deals with opposite and hypotenuse? Sine. Are we always going to use sine? No, just the two that we've picked so far, that's what it's been. We do the sine of our angle. What's the angle? X. We don't know it. So we put sine x equals opposite over hypotenuse. So what is it? 39 over 44. All right? Now, how are we going to find x? This is what we just got done doing back here on page 1. Up here, right here in the middle.
You got sine.
So we
Well, you push second and sine.
grab our calculator. We hit second, What trig ratio this time? Sine. And what do we put in?
39 divided by 40.
39 divided by 44, close the parentheses.
62.4.
So what do we round that off to?
62.
62 degrees. Be close enough. So what's the measure of that angle right there? 62 degrees. Could we find the measure of this angle? Yeah, we could add those two up, subtract from 180 and give us that. Could we find this side, the adjacent side over here? What would be the easiest way? We know two of the sides, what's the easiest to find the Pythagorean theorem? So could we find everything in that triangle? Give me another problem off that page, I don't care what it is. Or it could be off anywhere off the packet. We got 8 minutes. Don't care which one. Something to help Dakota get some of it done. Does this make any sense? What? 12?
I don't want to do the line.
Is that what you said? Huh?
There's word problems too, guys.
Like 54 through 60. 54 through 50.
Pick one.
58.
58. Thank you.
There we go.
Because there's word problems I don't feel like doing.
58. Yeah, you probably shouldn't have me do them because then I got to read. It takes forever.
I'll read it for you.
The town of Belmont restricts the height of flagpoles to 25 feet on any property. Lindsay wants to determine whether her school is in compliance with that regulation. Her eye level is 5.5 feet from the ground, and she stands 36 feet from the flagpole. If the angle of elevation is about 25 degrees, what is the height of the flagpole to the nearest tenth of a foot? Now the nice thing about this one, what did they do for you? They drew it out already. You didn't have to draw it yourself. Got her standing here. We got to remember she's 5.5 feet tall, I think they said, right?
Her eye level.
This is 36 feet. Yeah, that's to her eye level. I guess that's all we need. This is 25 degrees, and we're trying to find this side. So that's our X. That's a right angle there. Now, we got to remember, is this the height of the flagpole?
No.
No, what do we got to do? Add on that 5.5 when we're done to get the whole height. So which angle am I going to be dealing with? This one, that one, or that one? This one? That one, because why? It's the one we know. That's it. It's that simple. We know it, let's use it. What's that side going to be labeled? Opposite. What's that side labeled? Hypotenuse. Adjacent. Spectacular. Which one don't we care about this time? The hypotenuse. Or adjacent's in the game now. What do we do with that? What trig ratio deals with adjacent and opposite? So we do tangent. What's our angle? 25 equals what over what? Opposite over adjacent, which is 36. Ignore this. That's not another fraction bar up there.
No question. For like 22 and all those.
On this, ask me here in a second. On this, what do we do first?
You take the tangent of.
Find the tangent of 25. Get rid of the words. What's tangent of 25?
It's like.
0.4663.
663 equals x over 36. Ignore that straight line going out through there. Put that over 1. Cross multiply. What's that give us? X equals, nice on this one. Some of them you will have to divide. X won't be by itself. The 2 that we've done so far, or the 3 that we've done so far, X has been by itself the whole time. What's it come out to be on the other side? 16.8, 0.9, 16.8. Is that our answer?
Then you have 5.5.
You add the 5.5 to that. What do you get when you add the 5.5?
I have a few last-minute announcements.
22.2.
Reminder that the varsity track team to report to Coach Hampton's room after school to pick up.
Are
their
they in
uniforms.
compliance?
Also,
Said that
there will be a
flagpoles
volleyball
couldn't be
meeting
taller
for
than
girls
what?
interested in playing on Friday.
25 feet.
So
There will be meeting
Are
on
they okay?
Friday. Also,
Yeah,
all
they're in
girls 9th through
compliance.
11th that's
They're
interested in
okay.
playing. They will begin an intervention in Mr. Eilish room.
Do we want to do another one? While
Reminder
announcements
that
are
the high
on?
school still band.
Uh,
Rehearsal
well,
after
let's have
school
a
today
plan.
until
All right.
3:30.
But for 22,
Yep.
instead of like
Good
finding
luck to the
the
baseball and
first
softball
on the
teams.
sheet,
Where we at? We did that.
Oh, we did?
And I think that's all. Thank you and have a great day.
Oh, no, that's not what I want. Shoot.
Mr. McKnight to the high school office, please.
Yeah, but Michael, look back at it.
I mean, like,
So we got this triangle, right, for 22. This is 9, this is 12, that's 15. We want to deal with angle Z, right?
yeah.
So what's that side get labeled?
Uh,
Opposite. What's this side get labeled? Hypotenuse. And this side gets labeled the adjacent. We want the cosine of angle Z. Cosine deals with what two? Adjacent over hypotenuse. So we put 12 over 15.
oh,
If you left your answer on that section, if you left your answer as a fraction, I probably wouldn't throw a big fit. They said they wanted it changed to a decimal. But if you left it as a fraction, I'd probably be happy with that.
so basically, across from whatever they're asking for would be the.
That's the opposite leg. Whichever angle you're dealing with is your opposite leg.
Actually,